Hello everyone, welcome to my channel Learn Physics with MPG. I am Dr. Mrityunjay Prasad Ghosh, working as an assistant professor at SR University, Warangal, Telangana, India. So today we are going to discuss about series and parallel circuit and their equivalent resistance. So let's start with series circuit. So the circuit diagram which is shown in the PPT is a series circuit diagram. The circuit in which resistors are connected end to end. So there are three resistors R1, R2 and R3 which are connected end to end. So as a result there is a one path for current flow. So this type of circuit is called the series circuit. So here three resistors R1, R2 and R3 are connected end to end and a voltage source is also connected with this combination. So the current is flowing through one path. So in the above circuit, there is only one closed path and only one current flows through the all elements. So there are three resistors R1, R2 and R3. So one current is flowing through this resistance R1, R2 and R3. So this type of circuit combination is called the series circuit. So here if V voltage is applied to this combination, so V1 is the voltage drop across R1, V2 is the voltage drop across R2 and V3 is the voltage drop across R3. So here the voltage drop are additive in nature. So the V equal to V1 plus V2 plus V3. V is the applied voltage. So which must equal to the V1 plus V2 plus V3. So let's move to the next slide. So here this is the circuit diagram and this is the equivalent circuit. So V is the applied voltage to this circuit and I is the source current or current through the each element. Here R1, R2, R3 are the three resistors. So V1, V2 and V3 is the voltage across the R1, R2 and R3 resistor. So as per the Ohm's law, V equal to IR, that is the voltage drop is equal to the current into resistance. So V1 is the voltage drop across R1 which is equal to I R1. V2 is the voltage drop across R2 which is equal to I R2 and V3 is the voltage drop across R3 which is equal to I R3. So as per the Kirchhoff voltage law, this voltage drop across R1 V1, the voltage drop across R2 is V2 and across R3 is V3 which must be equal to V. So V equal to V1 plus V2 plus V3. So V1 is equal to I R1 as per the Ohm's law because the same amount of current is flowing through these resistors. The same amount of current, that is I, is flowing through R1, R2 and R3. So it is equal to I R1 plus I R2 plus I R3. And if this is the equivalent circuit and the equivalent circuit must have the resistance R equivalent, then the voltage drop across this equivalent resistance is also V. So we can replace V by I equivalent. I is the current through this equivalent circuit and R equivalent is the resistance of the equivalent circuit. So this must be equal to I into this combination R1 plus R2 plus R3. So we can easily calculate the equivalent resistance of this series circuit which is equal to R equivalent is equal to R1 plus R2 plus R3. So we see that for a series circuit the voltage drop across each resistor is additive in nature. So V1 plus V2 plus V3, this is the total applied voltage. Similarly, the resistance of the equivalent circuit is equal to is also additive in nature. So R equivalent is equal to R1 plus R2 plus R3 because there are three resistors in this circuit. So this is all about the series circuit equivalent resistance. So let's discuss some unique property of series circuit. So in the series circuit, the same amount of current is flowing through all the circuit elements. The voltage is distributed over all the resistor, or the voltage drop across each resistor. So if you sum the voltage drop across each resistor, or if you add the voltage drop across each resistor, in this circuit there are two resistors. So if you add the voltage drop across R1 and R2, then you will get the total supplied or applied voltage. So here the voltage is additive in nature. Also, the equivalent circuit resistance must be greater than the individual circuit resistance, or the individual resistance of the combination. This is because the resistance is additive in nature. So the equivalent resistance, or the total resistance RT, must be equal to the each resistance, that is R1 and R2, because the R2 and R1 are the individual resistance. So the equivalent resistance is RT equal to R1 plus R2. So the equivalent resistance must be greater than the individual resistance of the combination. Here the applied voltage is equal to the sum of different voltage drop across each resistor. So we have already told that here the voltage drop is additive in nature and power is IV. So the power is IV, or I square R, or V square by R. So it is the expression of power. So power is also additive in nature. So as you can see that the resistance is additive in nature, the voltage drop across each resistance must be equal to the applied voltage. So it is in additive nature, and the total power of the circuit, it must be additive in the nature. So this is all about the unique characteristic of series circuit. Now we will discuss about the application of series circuit. So as you can see that it can be used as a fan regulator. So where the when the variable voltage is given to the load, a variable resistor is connected in series with the load. So it is the concept of fan regulator. So fan regulator is connected in series with the fan. So you have seen the fan regulator in your home. Second, if you want to apply, or if you want to connect many low voltage lamp, then you need to connect them in series. So here the series combination is used in many lamp of low voltage where the which are operating to the main supply. And if you want to apply low voltage load to be operated on a high voltage supply, a fixed value of resistance is connected in series. So if you want to apply a low voltage load, so we need to connect with a fixed resistor in series connection. So these are the application of series circuits. So moving to the next slide. So what are the disadvantage of this series circuit? So as you have seen that here all the load are connected in series. So if a break occurs at any point in the circuit, so suppose one bulb is fused or not working properly or stop working, then no current will flow in the entire circuit and the circuit will become useless. So this is the one disadvantage of this circuit. And if you connect bulb one by one in this circuit in series combination, then the glow of the bulb will decrease, because to here the supply voltage, if V amount of V volt is applied to the one bulb, then it is equally divided to the each bulb. So if you connected more bulb, then the voltage drop across the bulb will decrease. So as a result, so you need to apply more voltage to maintain the glow of this bulb. So if you connect the same bulb which have the rated voltage 230 volt or a constant rated voltage, then the glow of the bulb will decrease if you connect all this bulb in series connection. So this is one of the major disadvantage of this circuit. And another is the electrical devices have different current rating, so they cannot be connected in series for efficient operation. So if you connect dissimilar circuit element in series connection, then you will not get the efficient operation if you connected all of them in series. So these are the major disadvantages of series equivalent circuit. Let's try to solve this problem. So this problem is related to the series circuit. So there are three resistor, that is 30 ohm, 25 ohm and 45 ohm. So they are connected in series with a 200 volt battery, right? So you need to calculate the equivalent resistance, the current through the circuit, and the potential drop across each element, potential drop across each resistor. So here all are connected in series. So we know that in series the resistance are additive in nature. So to find out the equivalent resistance, you need to add all the resistance. So you will get the equivalent resistance, that is 30 plus 25 plus 45 is equal to 100. So equivalent resistance of this circuit is 100 ohm. These are the resistor. Then you need to calculate the current through the circuit. So you have already calculated the equivalent resistance, which is 100 ohm. Then what is the current through this circuit? That is the potential drop or the potential applied to the circuit, that is 200 volt. 200 volt divided by 100 ohm, that is 2 ampere, by applying the Ohm's law. So now we need to calculate the voltage drop across each resistor. So here the same amount of current is flowing through this circuit. As we already know that in series connection, a same amount current is flowing through the each circuit element. So here 2 ampere current is flowing through 30 ohm resistor, 25 ohm resistor and 45 ohm resistor. So what is the voltage drop across this three resistor? So simply the Ohm's law, V equal to IR. So 2 ampere current is flowing through 30 ohm. So 2 into 30 equal to 60 volt. So 60 volt is the voltage drop across 30 ohm resistor. Whereas for 25 ohm, the 50 volt is the voltage drop across this resistor. Where for 45 ohm, the 2 into 45 ohm, 2 is the current, 2 ampere is the current flowing through the each resistor. So 2 into 45 ohm, that is 90 volt is the voltage drop across this 45 ohm resistor. So now if you add these three voltage drop, that is 90 plus 50 plus 60, so you will get the 200 volt, which is equal to the supply voltage. So here you will get the voltage drop across each resistor is equal to the supply voltage. So here voltage is additive in nature. So this is one of the unique property for series circuit. Now we will discuss the next problem. Here you need to calculate the unknown resistance R, where three resistor 5 ohm, 50 ohm, 10 ohm and an unknown resistance R, which are connected in series with 200 volt battery. So here you know the voltage drop across this 50 ohm resistor, which is 100 volt. So you can easily calculate the current using the Ohm's law, that is I equal to V by R. So I equal to V1 by R1. So the 2 ampere current is flowing through this 50 ohm resistor. So now as these all resistors are connected in series, so the same amount of current, that is the 2 ampere, is flowing through this circuit. So now we can easily calculate the voltage drop across this 10 ohm resistor, because the 2 ampere current, the same amount current is flowing through this 10 ohm resistor. So now you can easily calculate the voltage drop across 10 ohm resistor, that is IR2, that is 2 ampere into 10 volt, that is 20 volt. So you already know that the voltage is additive in nature for series circuit. So the voltage drop here 100 volt plus 20 volt across 10 ohm resistor, and here some unknown voltage V3, which must be equal to this 20 to 200 volt. So you can easily calculate, suppose this is V3, the voltage drop across this unknown resistance R, then V3 will be V minus 100 minus 20. So this supply voltage V is 200 and this is 100, and the voltage drop across 10 ohm is 20. So the voltage drop across this unknown resistance R3 is 80 volt. So you know the voltage drop across this unknown resistance, that is 80 volt, and the current, same amount of current is flowing through these three resistor, that is 2 ampere. So you can easily calculate the resistance using the Ohm's law. So R equal to V by I or V3 by I. So V3 is the voltage drop across this unknown resistance. So unknown resistance will be 40 ohm. The voltage drop across this unknown resistance is 80 volt, and the current flowing through this resistor is 2 ampere. So 80 by 2 is 40 ohm. So you 40 ohm. So you can easily calculate the unknown resistance if these resistance are connected in series combination, and the voltage drop across these three resistance is already given, and the voltage drop across any of one resistance is given. So this is the solution of this problem. So you can easily calculate the unknown resistance using series circuit combination. So in this lecture we have learned about the concept of series circuits, some unique properties of series circuits, application of series circuit, merit and demerit of series circuit, and we have solved some numerical problem based on series circuit. So in next slide we will discuss about the parallel circuits. So what is the definition of parallel circuit? In parallel circuit, all the resistor is connected in one end of the resistance, and one end of the resistor is connected to the one common point, and other end are joined to the another common point. So suppose this is a common point and this is also a common point. So all the resistance R1, R2 and R3 all are connected in one common point. One end is connected to one common point and another end is connected to another common point. So this type of circuit arrangement is known as a parallel circuit or parallel combination. So in this circuit, one end of all resistor is joined to a common point. This is one common point, and other end are connected to another common point. So this is the another common point. So this type of circuit combination is known as a parallel combination. So in this circuit, when a voltage or a supply voltage is applied to this type of combination, then the current, suppose I is the current flowing through the circuit, it is divided into different parts like I1, I2 and I3. So I1 current is flowing through R1 resistance, R2 current is flowing through I2 current is flowing through R2 resistance, and I3 current is flowing through the I3 current is flowing through the R3 resistance. So here the current in each resistor is different. So you can see that the current through R1 resistor through R2 resistor, R3 resistor, they are different. So I1 current is flowing through this R1 resistance, R2 current is flowing through this I2 current is flowing through this R2 resistance, and I3 current is flowing through this R3 resistance. So here, if you add these three current, I1 plus I2 plus I3, then we will get I. So here, current is additive in nature. So in series circuit, the same amount current is flowing through the circuit, but here different amount of current is flowing through different circuit element if they are connected in parallel combination. So here current is additive in nature, but the voltage drop across each resistance, suppose this is R1, R2 and R3, the voltage drop across R1 resistance, across R2 resistance and across R3 resistance are same. So V voltage is applied to each resistance. So voltage drop across R1 is V, across R2 is also V, and across R3 is also V. So here voltage drop across each resistor is same, but the current is additive nature. The current is divided in different circuit element. So the current is additive in nature. So I equal to I1 plus I2 plus I3. So I hope it is clear what is parallel circuit and what is parallel equivalent resistance. So now we calculate the equivalent resistance of this circuit. So R equivalent, this circuit combination is replaced by an equivalent resistance I R equivalent. So the V is the voltage applied across the each resistor, that is R1, R2 and R3. So the voltage drop across R1, R2 and R3 are same, that is V, but different amount of current I1, I2 and I3 flows through the I1 resistance, R2 resistance and R3 resistance. Here, by applying the Ohm's law, we can write the voltage drop across the R1 is V, then V by R1, the current is V by R1, the I2 current is V by R2, and I3 current is V by R3, because the voltage drop across each resistance is same. So now we know that the current is additive in nature. So total current I equal to I1 plus I2 plus I3. So total current I equal to I1 plus I2 plus I3. So I1 is equal to V by R1, I2 is equal to V by R2, and I3 is equal to V by R3. So you can write V1 by R1 plus V2 by R2 plus V3 by I3 equal to I. So I is the current through this equivalent circuit. So you can write I equal to V by R equivalent. So now you can easily calculate the equivalent resistance of this circuit, which is equal to 1 by 1 divided by R equivalent equal to 1 by R1 plus 1 by R2 plus 1 by R3. So you know that the conductance equal to 1 by resistance. So you can say in other word that the conductance in equivalent circuit, in equivalent parallel circuit, or the parallel circuit, for the parallel circuit combination, the conductance is additive in nature, or you can say that 1 by resistance, or the reciprocal of resistance, that is 1 by equivalent resistance 1 by R equivalent is reciprocal of 1 by R1 plus reciprocal of 1 by R2 and reciprocal of 1 by R3. So this is the equivalent resistance of parallel circuit combination. So I hope you have understood the equivalent parallel circuit. So what are the unique properties of this circuit? So here the voltage across each element is same. So voltage across R1, R2 and R3 are same, and the equivalent resistance must be less than the each resistor. That is, if R total is the equivalent resistance, then it must be less than R1. Also, it must be less than R2, and also it must be less than R3. So this is one of the unique property of parallel circuit. Another thing is power is additive in nature. Power is P equal to IV or I square R or V square by R. So this is power is additive in nature. The current is additive in nature. And what is G? G is called the conductance. Conductance is equal to 1 by resistance. So it is also additive in nature. So branch current, that is I1, I2, I3, these are the branch current, these are additive in nature, and the conductance, that is 1 by resistance, is also additive in nature. So these are the unique properties of parallel circuit equivalent resistance. I hope you got it. So what are the advantages of parallel circuit? So if you need the same voltage across each device, then you need to connect all the device in parallel. You need an independent operation. So each circuit element carries different amount of current. So each load can be, you can switch on or switch off. So each circuit element can be operate independently without affecting other. So the failure does not affect others. So if one circuit element fails or it is not working, then the other circuit element will work normally, because the voltage drop across each circuit element is the supply voltage. So it is suitable for household wiring. So in our house, the parallel circuit combination is used for wiring, because it supplies same amount of voltage to each circuit element. So if you apply different power rating circuit elements, then it can operate, it can be safely connected, and it can operate better when compared with the series circuits. So brightness here remain constant. So if you connect 3 or 4 bulbs in parallel combination, then the voltage drop across each bulb will be the same. So the brightness will be the same. So there is no change in brightness, and the additional load can be added without changing the performance of existing circuit elements, because the voltage across each circuit element is constant. So these are the advantages of parallel circuits. So what are the disadvantages of parallel circuit? So complex wiring. So here, for parallel circuit requires more wires and connection, because you need to connect all the circuit element at one common point. One end is connected to one common point, and another end of all circuit element is connected to another common point. So you need more wires. So higher cost if you need extra wiring, extra switch, and protect devices, then the automatic the cost of this type of wiring or this type of connection is expensive when compared with the series. Risks of overloading. So if many loads are connected, then the total current drawn can be very large, which may cause the overheating or damage the power source. So to avoid this overheating or the joule heating, you need a require thicker conductor. So we know that the resistance R is equal to rho L by A. Rho is the resistivity, L is the length of the conductor, and A is the area of the conductor. So if you take thicker wave, then the resistance will less, because the resistance is inversely proportional to the area of the wire. So there will be less heat generation in this circuit. Second, another disadvantage is the fault detection is difficult. So as there is, the wiring is complex in compared to the series circuit. So if there is any fault or short circuit, so it can be harder to detect in comparison to the series circuit. So increase power consumption. So here each devices gets full supply voltage because all the voltage drop across each circuit element is constant or is equal to the supply voltage. Then each devices get full voltage supply. So there is a increase of total power urge, total power uses. Now moving to the next circuit, next slide. So let's compare between the series and parallel circuit. Here the amount of current through each load is same in case of series circuit. For parallel circuit, the different amount of current is flowing through different load. Here load are arranged in a line. So in series all are connected in a line. Same amount of current is flowing through each circuit element because there is a one path for current flow. But in case of parallel circuit, the load are arranged parallel to each other. Here the voltage across each resistor is additive in nature. Here the voltage drop across each resistor is same. So if there is one breakdown, then the whole circuit will burn out or the circuit will not work. But here if one circuit element is not functioning, then another circuit elements will work normally. So there is no effect of this circuit element to the another circuit element present in the circuit which are connected in parallel manner. So now we will solve this problem. So this is the circuit diagram where two resistance 10 ohm and an unknown resistance R ohm which is connected in parallel to each other. The equivalent resistance in between the A point and B point is given. So this is 6 ohm. So we know that the equivalent resistance 1 by R equivalent is 1 by R1 plus 1 by R2. So the equivalent resistance is given, that is 6 ohm. The R1, let's consider at it as a R1 which is 10 ohm. We need to calculate this unknown resistance R. So as per the parallel circuit, the resistance 1 by R equivalent equal to 1 by R1 plus 1 by R2. So 1 by 6 equal to 1 by 10 into 1 by R1. So you can easily get the unknown resistance of this circuit which is equal to the 15 ohm. So now you understood how to calculate this unknown resistance if it is connected in parallel manner. Let's move to this circuit. So in this circuit, three resistor 2 ohm, 3 ohm and 4 ohm are connected in parallel. So if the total current is 8 ampere which is divided in this three resistor, that is I1, I2 and I3, then you need to calculate the equivalent resistance and current through each resistor. So you know how to calculate the equivalent resistance. So 1 by R equivalent, suppose this is R1, R2 and R3, then 1 by R equivalent is equal to 1 by R1 plus 1 by R2, this is R2 and plus 1 by R3. So R equivalent is equal to 1 by R1 plus 1 by R2 plus 1 by R3. This will be the equivalent resistance. So you can easily calculate the equivalent resistance here. So the voltage drop across each resistor is same. So you can easily calculate the voltage of this equivalent circuit. So equivalent resistance is 0.923. So the voltage drop across the equivalent resistance is 7.385. So you know that the same amount of voltage is applied to R1, R2 and R3. So you can easily calculate the current, you know the resistance, you know the voltage drop across each resistance. Then by applying Ohm's law, you can easily calculate I1, I2 and I3. So which is equal to 3.69 ampere for 2 ohm resistor. This amount of current is flowing through this 2 ohm resistor. 2.46, this amount of current is flowing through 3 ohm resistor, and 1.84, this amount of current is flowing through the 4 ohm resistor. So if you add these three current I1, I2 and I3, then you will get this equivalent current, which is equal to 8 ohm. So if you add these three, you will get 8 ohm, right? Because here the current is additive in nature. So I equal to I1 plus I2 plus I3. So I1 plus I2 plus I3, it must be equal to this 8 ohm, 8 ampere current, right? Did you get it? So in this lecture, we have already discussed about the basic concept of parallel circuit, application of parallel circuit, merits and demerits of parallel circuits, and we have solved some numerical problem based on parallel circuit. So thank you for your patience.